Good afternoon, everyone. Myself, Samarthita Sasmal. I am an assistant professor of the Department of Cybersecurity at Haldia Institute of Technology, Haldia, West Bengal. So today my topic is Data Encryption Standard, that is DES. And today I will be discussing about what is DES, how it works, and what are the important components and its related diagram and the strength and weakness of DES. And coming to our first slide, that is the overview of DES. Basically, DES is a symmetric key encryption algorithm, and you all know what is symmetric key encryption. Actually, in cryptography, a symmetric key is one that is used both to encrypt and decrypt the information. Means to decrypt information, one must have the same key that is used to encrypt it also. Means for both encrypt and decryption purpose, we will use the same key, and it is used to encrypt the electronic data. Now, what is electronic data? The electronic data is the information that is created, stored, or transmitted electronically, such as on a computer or other electronic devices. And first of all, it was developed in the early 1970s by the IBM researchers, and later adopted by NIST. And next, what is DES? Basically, DES is an algorithm that takes the input size of 64-bit, and it takes the key size of 64-bit also, and initially it will produce the same fixed length output also, that is also 64-bit. And now how it works, I will explain it by a suitable diagram. And initially there are so many components also. Actually, it looks like this. That is the initial permutation, XOR, sextil fistal round, final permutation, swapping, and the most important thing, that is S box, that is substitution box. So coming to our next slide, this is our related diagram, and now I will be explaining how DES actually works. So first, here you all may see that we have taken the plain text as 64 bits, and we will be producing the same length cipher text also. So initially we have used the initial key also, and that is also 64 bits, and the initial plain text that goes under initial permutation. What is initial permutation? That is nothing, just a permutation and a combination of the bits. That is initial permutation. And what is the initial key? Actually, for encryption algorithm, we all know that we will be using some key. So this is the initial key here, and this goes under permuted choice 1. And after going through permuted choice 1, that will produce 56-bit key. So now you may ask that where is how the bits are getting reduced? The 8-bit got reduced. And what is the process? Actually, every 8-bit means 8, 16, 24, 32, these every 8 bits means the every 8 bits called the parity bits, these will got discarded. Okay, this is permuted choice 1. So after got reducing the bits, we will get 56 bits, and now 56 bits will be divided into the 2 equal parts, that is named here like C0 and D0, 2 equal parts. Okay, means 28 and 28, and this will go next and under left circular shift, that is the LS. Okay, this will go under LS, left circular shift, left shift. And now you also may ask again that which are the bits we will be shifting. So here see, I am mentioning that I have mentioned that 1 to 9 and 16. When the bit number will be 1 to 9 and 16, so for that case we will be shifting by 1 bit. Means when will be the round number is 1 to 9 and 16, we will be shifting by 1 bit. But other than these bits, we will be shifting by 2 bits. Okay. And next, this will go under C1 and D1. Okay. And this goes under permuted choice 2. This is nothing but again the permutation and combination. Some some uh, some bits we will be neglecting, and after that we will be getting 48 bits. This permuted choice 2, it's like permutation compression. Means we will be discarding some bits, we will be compressing some bits. That is why we will be called as permuted choice 2. Okay, this is compression of bits, and after that we will be getting 48 bits, and these 48 bits goes under round 1. Means the initial permutation of 64 bits, and the after permuted choice 2, this 48 bits goes under round 1. Okay, and then round 1 will be happening, and these after round 1, the output of round 1, these will goes into round 2. Means the output of round 1 is the input for round 2. The similar way round 16 will be happening, and see the C1 and D1 goes again under LS, left shift. So the C1 and D1 is the input for the next round. Okay, so the PC2, like the 16 times this is happening, this is not the same. Okay, this is the rearranging of the bits, but these these PC2 and 48 bits messages are completely different. Okay, this is so much important, and by this way round 16 will be happening, and after that the final permutation. Means final permutation is the exactly the opposite of initial permutation. Means inversely we can say the inverse initial permutation. Means the exactly opposite of initial permutation, that is called as final permutation. So after operating the final permutation, we will be getting the ciphertext of fixed length. Means the 64 bits what we have given as the input. Okay. And now again the so many questions are arising, like this is happening, but what is exactly happening in round 1? What is round 1? How round 1 works? Okay, so that is I will be explaining the next slide. This is our second diagram, and now see the ALR. This is left plain text and this is right plain text, and here is our initial key, and these portions I have already explained. Now after happening the initial permutation, and the 64-bit message goes into round 1. The after entering into the round 1, this is the portion, that is I have divided the 64 bits into two equal parts, that is 32 and 32 bits. So left plain text consists of 32 bits, and right plain text is also consists of 32 bits. So here I have choosing right plain text to operate the things and the operation for choosing the happening the operations. And now see, this is 32 bits, and next this comes under expansion P. Expansion P means expansion permutation. Now see, after happening expansion permutation, the bits is 48 bits. Means we have expanded the 32 bits into the 48 bits. Okay, means we have expanded. And again, we will be happening the XOR. XOR is nothing, just the permutation and combination of the messages. Okay, and as I have already discussed the initial key, and that is also 48 bits. So 48 bits and 48 bits messages will be will be permuted again, and then we will be getting the same 48 bits message, and this will be going through the S box. This is the substitution box, and this is so much important component of DES algorithm. Just I am going to the next slide to make understand all of you the substitution box clearly. Now see, this is our S box, and here I have taken the 6-bit 1, 2, 3, 4, 5, 6, the 6-bit message, and now see the esteemed 2 bits. This is 1 and 0, and this will be the row. Okay, and this will be the row value, and the middle value, that is 0, 0, 0, 0. These 4 bits will be indicating the column. Okay, and here I have taken these bits, and one more thing, how many S box are there? 8. Okay, 8 S box are there. And that is why 8 4 is a 32 bits. Okay, because after getting these 6 bits and performing the S box, we have got the message of 4 bits, means 8 4 is a 32. That is why we got 32 bits message after performing the S box. And here what is happening, the 1 and 0 is the esteemed portion, so this will be indicating the row, and the middle portion will be indicating the columns. And here how many by if we consider like the 1 and 0 binary format, so by 1 and 0 how many combination we can get? That is 2 square, that is 4 combinations. Okay, and how many column combinations we can get? That is 2 to the power 4, that is 16. Okay, so means from starting 0 to 3 there are 4 rows, and from starting 16 columns. Okay, and here 1 and 0 is indicating the number 2, and 0 0 0 0 is indicating the value 0, means we will be indicating the intersection value of these 2 column and rows, means the column value is 0 and the row value is 0. So if we mark the column number of 0 and the row number of 2, the intersection point, this is our required value, and here we can see the value will be 4, and this is the 0 1 0 0, this is equal to 4. Okay, this is actually the substitution box. And now see, from 48 bits we will get reducing the bits to 32 bits, means 8 6 is a 48. After reducing, the 2 bits will be discarded and 8 substitution box are there, and 8 4 is a 32. Okay, and next again permutation will be happening, means the bit rearranging will be happening, and the XOR operation will be happening. Okay, and after that, after XOR is happening, the left plain text is adding here, and the swapping will be done. Okay, means XOR is happening and we will get the message, and then swapping. Nothing, just only swapping will be done. Okay, means right plain text will be left and left will be right. So this is our internal mechanism, and this is only happening in single round 1. and again round to round 16, means 16 times will be happening this mechanism. Okay, this is how actually DES works. And next, DES advancement cycle means to modify the DES, we can get the triple DES, and then from triple DES there is also very important encryption algorithm, that is AES, Advanced Encryption Standards. Okay, so DES actually can be modified by this way. And if it can discuss the complexity of DES, so for key generation this is order of 1, and for encryption and decryption actually this is happening for 16 times na, 16 rounds are there, so all the entire process will be happening for the 16 times, so the complexity is will be the order of 16. Okay, and the what will be the time complexity, this is order of 1 and order of n. Okay, for n for the for total round, and the space complexity will be order of 1. And now coming to the discussion of the strength of DES. So this is actually, DES was designed to provide the strong encryption security for its time, and this is relatively fast and efficient, and making it suitable for use in a wide range of applications. And DES is easy to implement and has been widely adopted by many industries also. And what are the weakness? Actually, DES use a relatively short 56-bit key, which makes it vulnerable to brute force attacks. And a team of researchers discussed that how DES could be cracked in less than 24 hours using a network of computers. Means there's a risk, okay, there risk of vulnerability, and the attack may be happen. So these are the major weakness of DES. And as compared to another encryption algorithm, DES is no longer considered a secure encryption. Okay. And next, we may conclude by saying that DES was a groundbreaking encryption algorithm that played a crucial role in securing electronic data, that I have already shared with you what is electronic data, and for the several decades. And however, due to its vulnerabilities, it has been replaced by more advanced encryption algorithm, that is AES. And it is important to stay up to date with the latest encryption technologies to ensure that our data remains secure. Okay, and finally, thank you all for listening my lecture today. Okay, thank you.